Okay, box experiences an applied force to the right of 7 newtons and a friction force of 4 newtons. What is its acceleration if it has a mass of 3 kilograms? So here are your steps. Step 1, you draw the object and label its forces. Step 2, identify the net force if it's 0, and if not, draw the direction it's in. This could also be acceleration. So if you don't know the net force, but you do know the acceleration, you could also do acceleration. And the reason is net force causes an acceleration. So if you have an acceleration, it's evidence of a net force. And if you have a net force, it will create an acceleration. So either of those will work when you're setting these up. Okay? Then you're going to label the direction that's positive, whatever that's going to be. Once you've labeled your positive direction, you're going to find the net force. And then once you find the net force, you're going to find the object's acceleration. Or whatever the missing force is, whichever it asks for you to do. So in this one, I'm going to start by drawing my box. And I'm going to draw the forces acting on it. Now, it mentions 2. It mentions an applied force to the right, Fa, and it mentions friction. Well, friction, it doesn't say the direction, but we know that friction is always against our motion. So if I'm pushing it right, then friction must be left. Friction listed is 4. Applied listed is 7. Okay, those are all the forces listed in the problem. That's all it tells me. Okay? Additionally, there are 2 more forces I know have to be here. 1, I know there has to be gravity because gravity pulls down on all objects. And because it's sitting on a surface and not falling or getting launched into the air, then I know there must be a normal force acting on it as well that works against gravity. It does not give me the number for them. It does not ask the number for them, so I don't need to find them, but it's important to label them so that we have it. We want to have that value so we have it if we need it. Okay, so we have done step 1. We drew the object and we labeled all the forces. Step 2, we need to identify the net force. If it's 0, or if it's not, then we need to draw the direction it's in. Now, it does not say 2 things in particular. So first of all, F net equals 0 if it's at rest or it says constant velocity. Notice this problem says neither of those. It does not say it's at rest and it does not say it's at a constant velocity. So therefore, we know the net force isn't 0. Okay, the net force isn't 0. Then what direction is it in? Well, it's not going to be up and down because my up and down are balanced. Okay, I'm not launching into the air, I'm not falling through the ground, so it's not up and down. So it's either left or right. So I'm looking at my numbers and I see that there is 7 to the right and 4 to the left. That means there's more net force to the right. That means the overall change in motion will be to the right. So I draw an arrow right and I write F net under it. That way I know the direction of the net force. Gabe. Oh, it doesn't say so. It doesn't have magic smiley faces next to it, so. They want you now. No, it's morning. You're always in trouble, Gabe. Okay? All right. Now, the third step. Identify the positive direction. Here's how I identify the positive direction. I identify the positive direction whichever way the object goes. So I am pushing it right, so I will make the positive direction right. Just because the net force is right doesn't mean it's moving that way. But in this case, I'm pushing it right and it's moving right. So I'm just going to put in front of the net force, I'm going to put a plus. Because that's going to be my positive direction. Okay, and now I've got all the setup stuff done. I've drawn it, I've labeled it, I found the net force, direction, and I labeled my positive direction. So now we get on to step 4, which is the actual math part. We got to find the net force. There are 2 ways to find the net force. There's way 1. That's a 2, but it should be a 1. And 2. Yeah, let's do different colors. 2 ways to find the net force. Now, you may be looking at this and say, Mr. B, I've never seen either of these. What's up with this? I don't know any of these. You actually do. This one here is A equals F net over M. In other words, Newton's second law. If you're wondering why it looks different, it's because we're going to be solving for net force as step 4 every time. So it's easier if the equation is F net equals instead of A equals. Okay? So by changing it around, I can use the equation immediately every time. And that makes it a lot easier. Okay? So if you're wondering why I rearranged it, that's why. The other one you're used to too. The other one, this Greek letter sigma, is weird to you. It means sum, as in S-U-M, not S-O-M. It means add the forces up, not pick a few of them. Okay? But this equation is this. F net equals F1 plus F2 plus whatever. In other words, rather than write out this big old nasty thing every time, it's just simpler to write it this way. F net equals sum of the forces. Okay? So in other words, add the forces up. So there are 2 ways I can find the net force. I can either multiply the mass and acceleration, or I can add the forces. Those are the 2 ways. So you have to decide for each problem which way you want to do it. So when I'm looking at this problem here, I'm looking and saying, okay, I know the mass. Do I know the acceleration? No. It says, what is the acceleration? So I can't do F net equals ma. Do I know the forces? I have an applied force to the right of 7 and a friction to the left of 4. I do know the forces, so I can add the forces up. So that's the equation I'm going to use. F net equals sum of the forces. Again, it's the Greek letter sigma. It kind of looks like a sideways W. And all I have to do is add the forces. And the forces are 7 in the positive direction, 4 in the negative, so that would be minus 4. Gives me a net force of 3. You like them apples. Okay. Again, the math of these is not designed to be challenging. The challenging part is making sure you get all the way through the problem. Okay, I found the net force. Now what? Find the missing force or find the acceleration. I want to know the acceleration. So I'm going to use this other equation, F net equals ma. I just found the net force to be 3. The problem said the mass is 3. Solve for A. Divide both sides by 3. And you get A is 1 meter per second squared. And that is my answer. Again, notice, none of the math is designed to be particularly awful. None of the math is designed to be particularly awful. It just takes some practice and some patience. If you do those 2 things, practice and patience, you're going to be in great shape on these. Okay? Any questions for me? Okay. Here's